All right, good morning. I would like to talk today about the three different forms of carbohydrates. So the first form of a carbohydrate is called a monosaccharide, and this is the most basic form of carbohydrates, also known as simple sugars, and this is classified by many hydroxyl groups and also one carbonyl group. So some examples of monosaccharides include glucose, fructose, galactose, ribose. The ose suffix is reserved for monosaccharides, and things like ribose and deoxyribose are very important because those are used in nucleic acids such as DNA and RNA. The second form of a carbohydrate is called a disaccharide, and these are formed from condensation reactions or glycosidic reactions, and how that works is the hydroxyl group and the which is the other one? I think it's the carbonyl group. They are put together when the two monosaccharides are near and the H2O gets pulled out, leaving only the O behind, and that forms a new bond, which would form the disaccharide. So you can see on the structures that there are things called anomeric carbons, and that's the carbon that is only bound to two oxygens. So the last form of a carbohydrate that I'd like to talk about today is the polysaccharides, and those are polymers of monosaccharides. They are also formed from condensation reactions. Some examples are glycogen and starch, and these are storage polysaccharides or complex carbohydrates, which means they are made from glucose monomers. So on these polysaccharides, there's different types of linkages or different ways that the molecule can be arranged. The first is the alpha 1,4, and that causes a helix or a spiral to be formed between the carbohydrates. And then if you have alpha 1,6, that causes branches, which makes it harder for them to be compact close in. And then there's also the beta 1,4, and I'm pretty sure beta also causes the carbohydrates to spiral or to be in a helix, but I'm not sure, I don't quite remember that. Some examples of these are amylose and amylopectin, and they are both starches found in plants, and then glycogen is found in animals. So that is all I'd like to talk about this morning. Thank you.